So we're going to go ahead and get started. Elizabeth has informed me that it's okay if you're facing the wrong direction, because she's only going to talk for a few minutes. So I'd like to introduce Elizabeth Thoren, who's going to talk to us about Inquiring Minds Want to Know, Part 1, and then after that, Brian will take Part 2.
Okay, hi, good morning, and yeah, we're all going to be working together today, so this will be fun. Okay, so first I'm going to tell you guys what we're going for here, and then we're going to spend most of the 25 minutes with you guys exploring a mathematical concept, which should be really fun. And we'll spend the last bit reflecting on that process. So that's sort of our outline. So the motivation is mathematicians think about things differently, but we don't really talk about what that process entails. And so our objective today is to become consciously aware of the questions we ask and the moves we make while we're doing mathematics. And the thing is, we want our students to leave us being able to do this process, but if we don't articulate the process, if we're not aware of it, how can we do our best at teaching it to them? So that's our goal today, is to become aware, at least of pieces. So what we're going to do is we're going to explore a mathematical idea called ghost legs, and I'll show you that in just a second. But as we explore, I want you guys to keep a record of the process. So record all your ideas, even the half-baked ones. Record any mathematical questions and ideas you're exploring. Record any mathematician moves you make. So anything you do, you feel like you're doing it because you're trained as a mathematician. And then keep track of your motivation behind those moves. Okay. So now I'm going to show you ghost legs. Okay, and I'll show you again in just a second. But let me just remind you what you're doing for your activity. There's mathematics in there. I know you guys can find it. So find a mathematical idea, maybe more than one. Record all your ideas, even the half-baked ones, all the mathematical questions and ideas you're exploring, any mathematician moves you make, and keep track of the motivation. Okay, so you're really journaling what you're doing. So I'll show you ghost legs again, and then you guys are set free to work. So this is what you guys have been doing. Okay. So now we're going to get ready to share some of the moves that you may have identified. So what I want you guys to do on this big paper is write down 3 mathematical moves that you identified. I mean, I'm sure you haven't had time to finish really exploring this, but think about the mathematical moves that you made, and then also while you're doing it, think about how those moves would look in other contexts. Well, that's what we're trying to figure out today. Mathematicians do things when they're studying problems that are very specific to mathematics, and we want to try to identify what those things are. So we're asking this room full of mathematicians to think about, while you're exploring, what are the things that feel like mathematician moves? So look back at your process and think about that. Oh, not about the game, not about the game. You guys have come up with some really great mathematical moves. So can I have a volunteer to share one of the first moves that they identified? And actually, could somebody hold up the paper? And then, yeah, Victor's going to share with us, but if someone could show us this for the camera, yeah.
So we came up with a fourth after the fact, so that's number 6.
But just share one, because we want everyone to be able to share one. You might cover a bunch of everyone else.
Our favorite, I think, was the last one.
Okay.
We intentionally tried to break things, and mathematically, I think that's looking for counterexamples.
Okay. So you intentionally tried to change the setup so that something wouldn't work?
Wouldn't work. Yeah.
Okay. Okay, does anybody else have a good move they want to share? Or who's next? Yeah, Mike. Okay, yeah, definitely I saw a lot of groups doing that. What is show me again how this works. Okay, who else wants to show their favorite move? Yeah, Alfonso. Yeah, the braid theory, yeah. So you made connections to mathematics you already knew about. Mm-hmm. That's a good one. Okay, Bob, you want to share your favorite or your group's favorite? Okay, so it's a little bit different than trying to break it, but you definitely said what happens if the setup is a little bit different. Yeah, that's a good one. This in the back. Okay, so looking for patterns, which again, like sort of extends on what Bob's group was saying. We should change the game and see if the pattern changes. Kind of, definitely. And then there's only two groups we haven't heard from, so what did you guys come up with?
So kind of the same
yeah.
thing as someone else, kind of the same thing as someone else looking at different situations. We simplified. We looked at what happens if there's only two boxes. What if,
so in a specific way, I think your microphone's not working. You're saying that you simplified, you looked at the two-box case.
Yeah.
And so that's definitely a mathematician move. If it's 3 is too complicated, go down to 2. Okay, and did you guys have a favorite move to share?
We're just really quite vague.
Okay.
Make observations, pose questions. Okay. Make observations, pose questions, make conjectures. So we were mostly just trying to figure out what the rules of the game were.
Okay, but
Yeah.
that's a different idea, this observation conjecture. So you're looking for patterns, and then the next step is make the observation, and then that generally leads to conjecture, right? Any other move you guys want to share that we missed? Yes, Ralph. Go from 3 to 4, so make it worse. See if you can generalize it, make it worse. So 3 to 2, simplify, 3 to 4, make it worse. Yeah, Mike.
One of the we had is to determine what we find interesting.
Okay, so this group, determine what we find interesting. So, and that's true, that's what's going to drive you to do more math. Okay, so you guys did a really excellent job. This is fun. Okay, oh, yes, Ralph. Oh, translating into mathematics, so writing down what, I mean, this was just colors and bars, right? Observe that some permutation was going on here, so then you can use all the mathematical symbols that we use for permutation.
Formalizing
Yeah,
notation.
formalizing.
I heard lots of existence, uniqueness questions floating around.
Okay, so so we would love for you guys to stick around for part 2, because what we're going to do is organize these moves into a coherent process and think about how to help our students learn these skills. And I also want to let you guys know that Brian Katz and I are running a contributed paper session called Teaching Inquiry at the joint math meetings this January. And what we're looking for is ways that you all have sort of introduced some process like this in your own classes. And that's really all we have for you for the first
Process like this meaning.
process like the mathematical thinking process, I guess.
Yes.
Doing
Where
mathematics
you explicitly try to make it
Well, yeah, so
conscious.
how you explicitly shared with your students that there is a mathematical thinking process and what you do to help them learn it. Yes? I was going to say, Ralph's asking why mathematical, isn't this more or less scientific? But I think there's some moves in here that were really specific to math. Making conjecture, well, I guess it's science. But it's a little bit different than the scientific method, right? That's the thing we're used to.
The scientific method will make an appearance in the next session.
So maybe the next talk will help clarify what we're going for. But yeah, I really hope you guys can stick around, and thank you all for being here.
Good job.